Okay, so to start, I'll just go over a few kind of commands that are pretty helpful when you start working with surfaces that aren't kind of flat. So those will be, to start here, I'll be using box morph, which you might have come across in tutorials. But also go over some ideas of kind of self-referencing the script and the surface itself, so you don't have to constantly tweak a million variables depending on the surface. And also go into getting like surface normals and kind of vectors, and also working with the curve of the shape. So to start, I'm going to be putting kind of this little shape I've made right here kind of onto this surface and kind of tiled across it. And there's kind of multiple ways you can do this, and I've kind of picked, or I'll do it two different ways. But kind of getting a panel across the surface is kind of like the first step in a lot of kind of Grasshopper tutorials. And I won't be using any plugins, but if you do have a script where you want to kind of panelize a surface, I would suggest getting Lunchbox, which is a plugin, or Paneling Tools, which both do it much better than kind of the Grasshopper straight out of the box. And it gives you a lot more options. You can panel things like triangular, or a diagrid, or even like space frames just with kind of one little widget. So I won't use those here, but I'll just use a different way. But if you need to start paneling things, those two plugins are extremely helpful. So to start, I'm just going to turn this off, and I'll just redo this just over here. So just kind of looking at that shape, sorry. To kind of recreate it, it's pretty simple. I'm just going to start with kind of a base rectangle, and that is just this command right here. So create rectangle on a plane, and it's going to ask for kind of where to start it, if you fillet the corners, and also the dimensions. So I'm just going to make it a square. Actually, let's make it bigger. And plug those into the X and Y. And you can see it's pretty faint, but there is a green rectangle, 8 by 8. Alright, so I'm then going to create the kind of top circle here. And to do that, I'm just going to want to start a circle right in the middle, and then I'm going to move it up. So to get the middle of a rectangle, or the middle of anything, the area command, which doesn't seem intuitive at the beginning, but the area command gives you both the area and the centroid of the geometry. So a lot of times I'll use this just, you know, if you want to scale this circle or this square or any shape towards its middle, or like this, just get the center for a different started geometry, the area command will do that. So then the circle, which is this one. So I'll just put the starting point, so the base plane, as the center of that, and you see the circle appears, and let's just give it a radius of 4. Oh, not 4. Let's make it like that. And then to kind of finalize this shape, I'm going to move that up. So the move command, you're going to put it world up, which is Z or Z. Let's move that a little further. I'll get rid of this. Oops. So there you see we have our kind of base rectangle and the top circle. And then I'm just going to loft between those two. So take my rectangle here and my circle while holding shift. You'll see that it lofted between the two, but it's not, I mean, that might be what you want. But just like when you click loft in Rhino, options come up. You can get those same options within Grasshopper. And sometimes it will do it exactly how you want, but if not, loft options is kind of this checkbox type widget with all the options, and the thing that will fix that, which will fix a lot of them, is just this adjust here, and it's just saying adjust seams. It's false right now, so there are a few ways to put true or false in, but the easiest way is just Boolean toggle. So that's just going to give you a switch that toggles between true and false. And if you click that in, you get there. So it's kind of realign the seams to make a loft a little more like we want. And the other options on this are loft options is the ones that come up in the box if you did it in Rhino, and it's just closed, rebuild, the type of loft, so loose, smooth, tight, straight. So you should have seen those if you've ever lofted kind of within Rhino. So there we kind of have a base geometry, and really that could be anything we wanted. I just did this for the sake of it being relatively easy. And again, we can change kind of the size of it here, but you'll see we'll start playing with the size when we morph this object. All right. So just to make things easy,
those variability be enough to satisfy the requirements of this assignment, or would you want to see more? Like the size
well,
of the handle?
you'll see that when I put it on the actual surface, those variables aren't actually going to be changing. So if there were other variables, it will make sense in a second, but if you could change those, if you change those, like the opening or the height, like on the surface, so your surface was responding to either, a tractor or image or the curve of the surface it's on, then I would say that satisfies the requirements. But these ones right here, I'm just kind of creating this base shape, and you'll see these won't actually be kind of variable on the surface itself. But I'll show you how to do that in a second, or later. All right, so just to make things easy, I just use these containers. So, all these are just empty kind of containers. So this is a B-rep. I'm just going to put it into here, and we're going to start kind of our next step. I'll turn these off. All right. So what box morph does is basically takes whatever is in one box and fits it into another box. So let's see. We'll go bounding box. So what bounding box is basically just puts whatever you put into it. It makes a box that contains the whole kind of object. So you'll see here, it's kind of outlined, or it's kind of contained that whole shape within a box. So this is kind of it creates a reference for the shape, and it's also what's going to be moved to kind of our second box. So to create that kind of second box, I'm just going to create, let's do center box. So that's just creating a box centered on a plane, and it's going to ask for X, Y, and Z. So just its width, height, and length. So just let's put in 10 for all of them. Okay, so let me. And I'm just doing this right here. Just to get them out of the way of each other, so it's easy to see. But this top one here is just the kind of the base plane. So if you put whenever it asks for a base plane, you can either put just a point or a plane into it, and that's just kind of where it starts. So if we use box morph here, box morph, right? It comes up as just morph, and it's just going to ask for our geometry, the reference box, and the target box. So we have our geometry, we have our reference box and the target. If we do this, let me hide this. You'll see that it's basically put this shape into kind of the target. And just kind of, obviously I'm changing these all together, but if these were all different, see, it's taking that shape and basically, you know, my target box, as my target box changes, kind of the base shape follows along with it as well. So obviously that is not on a surface yet, but the same idea can be used when you can what you can do is divide the surface up so you can panelize it, and then on each panel you create a box, and then basically that shape will fit along the surface. So, and the reason it works so well is because when you divide it up, not every box will be the same width and height. You know, as like if you panelize this equally, where it gets thinner, your panels are going to be smaller. But because it's fitting this shape into all the boxes created, it's going to kind of fill up that whole shape, no matter kind of what size is the box and how they're varying as well. So, all right. So let me get that surface in. All right. So kind of the main way, or the kind of the base way to subdivide a surface with just Grasshopper is to first divide. Is that one? Yeah. So that was divide domain first. So surface goes into the I, which is asking for a base domain. And then it's asking for the number of segments in each direction. So those are 10, but let's just put this in here for 10. And then surface, right. So the next command we're going to use is surface box. So this will create a twisted box on a surface patch. So if it's going to ask for the domain, which we've created here, and the surface. So put that into S and this one into D. You'll see that it's divided up the surface and created a box kind of on each panel. And H here is the height. So just for the sake of this, on this one, they're all going kind of inwards. I want them to go kind of out of the surface. So right now it's just going in 1. So if I put that to something like 5, again it's going to go inwards. The easy way to get around that is just to put the negative command. So this will just put in kind of -5 in there. So now that surface is kind of filled up with the boxes. And now, if we use the same command we use up here, so that's box morph, and we're going to put not the surface, but kind of this original geometry again into the G, its bounding box in the R, and then that there. We now have kind of that. Turn these off. So that shape kind of panelized across that surface. And you'll see that, again, all the boxes are not exactly the same size, but it's fitted kind of perfectly into each kind of panel. And it's down here where it's at, or the height of the boxes is where we would kind of change that, or the height here. And then also the divisions. So right now it's dividing at a surface 10 by 10. We can again change that. here to change how that surface is being divided.
How do you know which letters you plug in? Is it the box marks and G?
Right. So it's just it was just asking, like on this one, I only knew off the top of my head because I've used this before, but G was asking for the base geometry. R was so I always, if I haven't used it before, this is where I would go first to try to figure it out. And even some of them are a little cryptic, so you just start plugging things into other things. But this one's asking for the reference and then the target. So again, these ones were where we wanted them to go. So this was our target box. This bounding box here was the reference one, and then our actual geometry was here.
Is there a way of when you change the height of all of them? Is there a way of like
Yeah, so because it's just this is just one height, it's basically putting that height to everyone. But if this was, I'm going to assume this is going to work. A random, let's go. Alright, so what I just did there was to use the random, just to see what happens. The random command, so the random one's going to ask for the domain. So my random numbers are going to be between 0 and 10. It asks for how many. So I just used the list length command to find how many different boxes I had. So that being 36, so that's going to give me 36 random numbers. And this bottom one here is just the seed, which kind of dictates the list of random numbers, but for the most part you can just leave that. So if I put this into here, there. So obviously this is just random. At this point I could have used basically anything to get a list of 36 numbers. So calculating the curvature of this, which we'll actually do later, or an image map, or attractor points, or kind of whatever you wanted to do. So that's just basically lining up each of these boxes with a different random height, if that makes sense. Right. So kind of one of the important thing to remember when you're using, if I wanted this to work on kind of any surface that I plugged into it, you kind of want it to self-reference or start to learn about the surface you're plugging in and make changes based off that, rather than you having to always change every single variable. And in a simple example of that, let's just say this was kind of the size of panel I always wanted. So this was a certain 300 millimeters by 300, and I always wanted it to be that. Obviously, if I switch this surface up and made it a lot smaller, it's not going to make it smaller, but one sec, it's thinking. Well, what I've at the beginning I told it to divide it 10 by 10. So no matter what shape I put in there, it would now divide it 10 lengthwise and 10 in the other direction. Now if I gave it kind of a super skinny piece, long and skinny, obviously that would start to look a little weird. You'd still get 10 in both directions. Still thinking. So let's just see. Again, if I stretch it this way, the actual widgets on it are going to start to get deformed. And if there was something I was actually going after, I would want to start thinking, like as you can see here, I would start to want to think about it in a way where I kind of measured the surface beforehand and then divided it maybe based on its dimensions. And also things like, in this example here, I didn't use a specific direction like X, Y, or Z. But in a lot of times you will, when you're making a surface at the beginning, kind of use those. So you'll want to start using, finding the actual like normal at like the center point of each of those shapes to be able to extrude off of, or kind of things like that. So instead of having all these values you have to change yourself, like once you've put in a new surface to make it look good, try to design those things into the definition at the beginning, so no matter what surface you put in, it will always kind of look similar. So to deal with this kind of stretching when the thing is stretched, I'll kind of want to change this part here where I just divide it 6 by 6. So one thing you can do is use the dimension command. So that's just going to give the dimensions of a surface. So if I put this surface in here, it's now going to tell me its kind of dimension in both directions. So it's 246 probably millimeters in one direction and 127 in the other. So if I kind of want relatively square panels, I could then take those dimensions and divide them, or sorry, just division. So I'm going to divide one length and the other length, and let's say I'm going to put 6 in for now, and you'll see what this starts to do. And now I'm going to use those numbers here. Actually, let's make this bigger. I'm going to use those numbers here as my kind of divide numbers. So now it should give shapes that are approximately 10 by 10 if you follow the math. But actually, one thing I have to do beforehand is round. So these numbers here are like 24.6 in this one. You can use the round command just to get those to nice even numbers. So if I go there, there. So now no matter kind of what you'll see when I change this, it's not going to change the size of those panels. It's just going to do, if I make it smaller, less of them. So they'll never ever be stretched, or they won't kind of start to look weird. It's going to kind of figure out what I put in there and kind of base the amount that to put on it based on that. And it's that kind of stuff that you'll find kind of helps to make your Grasshopper definitions kind of available for a bunch of different surfaces you put in, and you won't have to mess around with them as much.
Will you be stress testing our definitions to try and make them break, or?
I don't think they'll be doing that. No. But it's in the future, so you probably wouldn't have to do that for this. Like, this is a requirement for this one. But you'll find, especially when you start, if you start testing something on a flat one, and then try to put it on something curved, it's a lot easier if these kind of things are built in. And also, like if you're doing a studio project and you've kind of designed your paneling system, but your form, always gets tweaked or starts to change every once in a while, it's a lot easier if the same kind of definition can be easily put onto different forms, rather than every single time having to play with, all these little sliders within your thing. And it could be, these are actual, if these were going to be built, that the panel size is a strict, like 300 by 300. So that should be built into your definition, and you won't have to like try to divide the surface enough so that everyone's like approximately 300. That kind of coding is built into it.
What kind of surfaces will it be tested against? Something like that, or will you be putting a sphere and a cube together and gluing them together? And you have to
No, for this project, it's just your own shape.
Oh, okay.
So design your Grasshopper definition for like the 3D surface you've kind of put into it. And if it doesn't just automatically work on other ones, that's fine for this assignment. But in the grand scheme of things, when you start going down the line, they should be able to kind of accept a little more variability. Yeah.
So you built your surface off a 2D plane or your grid. Can you go back to the beginning of your workflow and say, now I want to make my surface 3D, so just add it in at the beginning? Is that possible?
When I finish these ones and start doing the coffee one, the first thing I'll do is just put the coffee definition onto a 3D thing, and you'll see that part of it works, not all of it. So if you've designed your thing and you just plug it into a curved surface and it works, then that's perfect. But most likely some things will break, and then you'll just have to go through it kind of step by step and seeing where it's breaking, and then kind of translate that so it works in a third dimension.
I guess what I'm wondering is, does it make more sense to try and do that at the beginning, like to remap the grid to a surface at the beginning, or to do it at the end when you have your whatever?
Well, it's for like the logic and making almost everything else work, it's easier to do it on a flat plane. To do it like all in one go, it's obviously easier to start with a curved one. And if if you feel comfortable starting on the 3D object at the beginning, then that might be a better way to do it. But a lot of times, if you start, just start with a flat and then see how it translates, and then you'll just have to fix it after. But I guess it kind of depends how you want to kind of go. But
So we are or are not allowed to use curved 2D surface?
I would say this is a 3D surface.
And so if this was our project, our original pattern, would it be like the original you're estimating?
Yeah, so it might even be, this is a surface, but it could be a lot more curvy and complex than this one. So I would say if you were, like your original one might just be, if you found some material thing that is more like, so maybe that was like your original material pattern thing, right?
And then, so when we're doing our system innovations, we're just editing it on the surface, not
Yes, I believe so. Yeah. And obviously I just use random here, so it's, that's not very exciting. There's a lot, there's a lot more kind of ways with some intent to edit all these things depending on your surface. So kind of random is kind of boring, but it's just.
So what are the other ways to
curve, like a image. Oh, okay, curve, image maps, and attractor points. Like those are kind of easy ones. It could be. Grasshopper has the power to do everything from like. It could read, a webcam and respond to your movements. Like that is like it can do almost anything. So basically, you're just trying to get with curve, with image maps, and with attractor points. You're basically just getting a list of numbers. So that's getting random is just getting a list of numbers. So those kind of three that I just mentioned are probably the most kind of common ways. I'll go over the curvature and the image maps kind of in the next example. And you'll see how they're kind of just, image maps are easy to change because you're basically just drawing a picture and then it's responding to that picture. So you could make 16 iterations of that really easily. Curvature, it's reading the curvature of the surface it's on. So I don't know if I mean, the surface curvature could change, or you could change the values kind of related to how it's responding to the curvature. Let's see what other ways. Yeah, those. You could have it. My I'll try not to brag, but my project last year through Grasshopper responded to Twitter. So it just was reading a Twitter account, and every time it got a tweet, it changed its color. So it's like there's plugins to get input from like anywhere, from Excel files, Twitter, Facebook, webcams, like sensors. I mean, obviously it's getting a little complex, but even when it's getting information from Twitter, all that's doing is counting like the amount of responses, and it's just turning that into a list of data. So all this is asking for is 36 different numbers. So there's like a million ways you can get 36 different values, like in this example here. But I know image maps are probably the ones I use the most, because it gives you like almost direct kind of control. So just in Photoshop, you make an image from black and white, and you can even do it down to the pixel. So like the last project I just did, each pixel was like a piece of, what was a box that either extruded or came back. So down to like, instead of having to do it in Rhino where I'm like sliding all these geometry back and forth to get the image I wanted, it was just use Photoshop, like a 20 by 20 pixel image, and just the black ones were out and the white ones were in. And you could pump out like those like 20 a minute of just different variations of how the boxes lined up. So something like that is pretty powerful. I mean, in this assignment, but also in kind of anything you do in Grasshopper. So I might kind of start with those basic ones, but if you feel like hooking up your definition to the internet, go ahead.
And what does that lunchbox plugin got us for the other panel?
All right, so let's. I have lunchbox up here somewhere. All right, so if I hide these, the lunchbox command. Let me just get this surface. So basically, the ones that I use the most up here are panels and structure. So something like diamond panels. There, we have like space trusses. Or that's not going to work. Something like, so this is created like a space frame on the surface. Yeah. A lot of stuff. Yeah. And it's pretty powerful too, because well, I guess in my I'll show you from there you can kind of almost do kind of anything. So let me see. All right. So obviously box morph gives you that option of kind of creating that kind of base condition and then paneling it on the surface. I've used box morph actually very rarely, and kind of starting with a panel and then building from there is what I would usually do. But I mean, both are powerful, so I just have done one over the other. But I'll show you how I would typically do a paneling thing like this. So let me just get rid of some of this. All right. So I'm keeping the surface, it being panelized kind of equally, and then it's being divided. So from there, without using Lunchbox, so this is where I might use it, but I'm just going to go ISO trim. So ISO trim will basically take your kind of divisions of the surface and make a bunch of little surfaces from that. So you'll see if I put my base surface here into the S, base surface, and then D is asking for domains, and that's what we've created here. Right. So I'm gonna just hide that. Right, so now I've made a surface, and you can see that each one of these little squares is a surface on its own. So it's from here where I usually, another way to kind of start building a paneled system is. So to kind of get kind of tools to work with, I usually explode these. So deconstruct brep will kind of divide each of these surfaces up into its face, its edges, and its vertices. So from here, I'm going to create something almost similar to what we just had, but just using kind of this different way. So I'm going to want to scale. So right now I have the edges, which is basically each of these surfaces, kind of the curve that goes around it. They are divided into separate parts right now, so I'm just going to join those. Oh, that's not the right one. Join curves. And that is just making, so for example, for this surface right here, when I exploded it, each of these were separate lines, and I've just joined them together. I'm going to scale them towards the center. So if I use the scale command just as it is, you'll see that it scales kind of all of them together, and it scales it towards 0, 0. As you want to scale each one kind of towards the center of itself, you're going to have to find the center of each surface, so that's where area comes in. And if I just take my surfaces here, you'll see that it has put a point now at each center. And I'm going to use this C here, which is the center of each geometry, as the scale. Oh, wait, 1 second. All right. Yeah, but that is actually wrong, because you can see we have a bunch of different branches here, and I just put it this, and it's doing something funky. So I'm actually should be doing this. There. So I took the face, and this is just in the same kind of branch structure as the edges. So that's going to give me now kind of an interior line on each surface. So here, I'm going to want to extrude these out, basically directly out of the surface at each spot. So here's where I'm going to want to find the normals at each of those locations. So to do that, evaluate surface is going to ask for base surface and the UV coordinates, and then it can output the point and also the normals. So this is what we want. To get kind of the UV coordinates to evaluate, though, the surface closest point. So these two I almost always use together, because this one asks for the UV coordinates, which are kind of like the local coordinates of this surface. So we have all our points. I'm just going to use these kind of center points again, because it's kind of the center point of the whole shape, so this is a good point to kind of use. So that goes into point, surface goes into surface. And you'll also see some of these areas were not exactly on the surface, just because of the way it's calculating the center of the area, or center of the shape. But this surface closest point will kind of find that point that's basically right near it, that's directly on the surface. And it also gives us what we're looking for here. It's the UV coordinates. So again, if I put the surface into surface, and this the UV into the UV. What it's showing now is basically just the frame. So this is kind of like the normal kind of base plane at each of those points, but you can just turn that off. So now we have kind of that direction directly out of the center on each of these panels. And from there, we're basically just going to move this shape up. So to do that, I'm going to use move. We have kind of our interior shapes, so into the geometry. And you see without kind of putting the normals in, it's just moved them all kind of directly up, which is what we don't want. But if we put our normal directions into the here, again you'll see that it's starting to move it in the right direction. But to get some control over that, so what N is basically just direction. It doesn't really have a strength attached to it. So to add so we have the direction to just add a strength. It's amplitude. So that will set a length of a vector. So vector goes into V, and here's where we're going to add just a value of, and I'm going to assume it's probably going to have to be a negative number. There. And you see that's now moving that kind of base shape directly normal to kind of where it is on the surface. And from there, move this. If we again just loft between this exterior shape and the interior one, so that would be this one here, where we joined them into a kind of a one curve, and this there. All right. And again, similar to when we're using box morph, this value right now is just changing them all together. And also on the scale command here, we haven't put a value in here, but right now it's scaling it by 0.5. If we do put something in there, we now have control over kind of that top part. So this is giving us kind of a few extra kind of control points than the box morph. Sure.
So if right now we have nothing to do with the original geometry that created, are we going to apply the original geometry onto the whole house? But coincidentally, they look the same.
Right.
They're not.
Well, these are kind of techniques how you can kind of get stuff working on a 3D surface. Right after this, I'll do the coffee one. So I'll have the coffee one and see what happens. And it does. I did get it to work on a 3D surface, but I mean, you might, when you put yours into a 3D surface, you'll probably find you'll either have to start getting normals, getting what did I have to do on the other one? Probably a lot to do with paneling or the sizes. So you'll probably have to use some of these techniques to get yours working on kind of a surface that's more curved. All right. So on this one here, we have control of both the scale of kind of that one there, and also the actual extrusion. So let's do the curvature example. So what is this? This is going to do is basically at each of these points measure the curvature of the surface it's on, and it's going to just give us a value, and we'll use that value for either the height or the opening size. So this is something you might want to do on yours. So curvature is surface curvature. That's evaluating the surface at a specific coordinate. So it's going to want our base surface here, and then again UV coordinates. We've already found those. Right, so if you've already kind of got something once in your definition, try not to do the same command to get it again, because it's just going to bog it down pretty quickly. So we can use the same UV coordinates that we found here. Let's move that down here. And what that is giving us is a bunch of values measuring the curvature at each of those spots. Sorry. But if we get these values, they're all kind of extremely small. So kind of using these values as they are would be pretty useless. So what we're going to do, and you'll find that you'll probably have to do you're going to have to do it with image maps, curvature, most likely attractor points, is kind of remap the values into the ones you want. So it's basically going to take this range of values and kind of move them all between kind of a better kind of preset, or whatever you set, kind of set of values. So to do that, we're going to use the remap numbers command. So that's going to ask for the value to remap, the source domain, and the target domain. So the values we want to remap is easy. It's just our curvature values. And don't ask what the difference between these two are. But this one seems to work. So our source domain is kind of the range of numbers that we have already. So to get that, the bounds command. So this is just going to kind of give us all these values. But if you see, right now, these values are all just a list of 1. So if I put this in as it is, what we're going to get out is a range kind of for each list, which isn't what we want. We kind of want the range of kind of all the numbers together. So just right here, I'm going to flatten this one. So not flattening kind of our actual data, but just to find this the bounds here. And it's giving us the range of numbers kind of for all of them combined. So I'm going to use this as my source domain, and target domain is just going to ask for kind of where you want to move these numbers to. So to create a domain, they type in domain, it is construct domain, and not, there's a bunch that look really similar, so not any of the cute squared ones, just this construct domain here. And that's just going to ask us kind of for 2 numbers, kind of the beginning and the end. So if we want, let's say we're doing, this is going to change our heights. Let's say 2 as a low and 6 as a high. So you see when I put those in here, it's now created a domain. You can read that, it just says 2 to 6. So by combining all that, we now get a list of values based off the curvature, which is between 2 and 6, rather than like minus 0.001. So if I use this as my height, which is here, actually let's vary this a bit more. See, this it's pretty evenly curved, but you see that you start to get variation. Actually, I'm just going to cut this down. There you go. You start to see variation kind of based off the curve of the surface it's on. So if I change the surface, it would be a completely different kind of pattern. Again, if I put this, I could use the same curvature, but to change the dimension of this top scaling. So I could use this again, and let's just copy this part here. But now we're going to want something between kind of 0 and 1, because that's the values this kind of scale thing commands, or scale thing uses. So let's go between 0.1 and 0.9. So now we have those values based on the curvature between these two, and if we use that as scale, you can see that we also start to get variation on the opening size as well, based off just the curvature. And for something like doing the image map or the anything else, you just kind of replace this step here. So this is just generating my list of kind of values. So I could kind of get this any other way. But again, I would most likely need to remap them because they're not going to be in the kind of thing I want. All right. So does that so far kind of make sense? Any questions?
So basically everything you're showing us on the surface in terms of variation that would help.
Yes. So I don't know if we want to take a small break, and then I'll just go over the coffee one and how to get that kind of from this flat thing that we made without even thinking about curved surfaces, and how to get that working on a curved surface. So like 10 minutes, 10, 20. Do that.
Variations that you're showing, like different ways to create them, aren't like what is expected of the.
Well, yeah. So they don't need to be made different ways. They would use different like inputs for its
so like
variables
or whatever.
Yeah.
Like, okay, increasing the height by 10 or decreasing the height. Not like this.
And it
is
says
a
and it says a couple of them need to be based off like external. So that's more in reference to like using the curve or an image map. So some you can
or
just
like changing,
yeah.
like you did, like you elongated your curve. Or
Yeah. So I'll bring up that.
this assignment is insane.
I know.
Any chance they're going to be like, what's actually required?
Well, in the email today, they're like, or Jody told me, good luck, and you might get a lot of questions about extensions. So if obviously I have no idea.
I'm gonna ask for that.
Well, I have a studio project I haven't started due tomorrow, so
Okay, fun. Well, we won't bother.
I need to ask for extensions as well.
Yep.
Question for you.
Sure.
First off, the 16 iterations.
Yes.
They want 1 or 2, or like 2 minimum, but like, where else do they want the other 14 to go?
Yeah. Let me see. Let me get this.
I read that. I was like, what?
Is it on here somewhere? Yeah.
Yeah.
Let me check workflow.
It just says deliverables, a diagram of the parametric system, which I'm not 100%
Right.
sure.
Actually, third side.
Page 3 of 4, and then a phylogram, and then detailed image of the most interesting instances across the series. And then
So,
doesn't say what number.
Up here.
no. Yeah.
So
Right.
that was the other ones.
So on this part here, so this is pretty basic, right? My definition right here. But so it would be 16 different ones changing variables such as like the height and the opening size.
And how do you want those documented? Like screenshots, or do you want each one?
Well, I think it said Let's see what.
That's a really confusing thing.
I would go. So not all of them generate. Yeah. How would I do that? Because it says. Okay. Yeah, so you have to show 5 for sure. So 5, like
And how would they know that
5.
we did the
But you also
16?
should show, like, I guess the phylograms for. I would document each of your like chain like variables. So show somehow the 16 different things you did, but you don't need to show like the output of all of those.
How do we
So like
in
if I
the
was changing,
phylogram, that's how you show 16 words.
yes,
Oh, okay.
yes. So I would like
we're gonna kind of taking a snapshot of Grasshopper with all this.
well no the
Is that what it is?
no.
Hologram is literally text.
It's basically just a graph of like the hierarchy of something. So like if I had 3 variables, 3 major ones that I was changing, I would like your first branch of the phylogram might be like 3 branches,
Yeah.
right? So ones you kept this variable the same, the
Okay.
next ones you kept this variable the same, and the final one you kept that variable the same.
And then
but then
maybe
in the first
2,
one,
1.
yeah, so in the
Yeah.
first one you then did 3 options, changing the other 2 variables, 3 options.
Yeah.
So it like breaks down.
Yeah.
So you basically have you would have 16 final iterations of things,
Same thing, different.
but based on like what you did to it, they kind of break down into different, like it's like a family tree of all your changes.
And do you have an example of what that would look like online possible? I've gone through that kind of only biology.
Yeah, so that's basically a phylogram is a actually I had to do, it must be like a big thing this year because I already had to make a phylogram for something. It is for, but it was slightly different. Well, that's extract graft. There is.
So we have to produce one high resolution image of the 5 image.
This project should have been given to us 2 weeks ago when we had a week off.
Well, they were being kind to us.
For what though? We could have at least fucked around with Grasshopper in our spare time.
They did tell us to do that.
But I mean, we could have at
For
least done it
people who
within
went
the
to
concept of
LA.
it. Yeah.
I'd like to think that LA was just like all chill, but actually a lot of like
A lot of buses and traffic.
yeah. I tried to do work on the bus and it was just like
You're gonna have time to go upstairs today.
you better.
Yes, later sometime.
Like later in the afternoon?
Yes.
Should only have Josh.
Yeah, we have studio from 2 to
Oh.
6.
Yeah.
I just need some like kind of personal advice before I can go on with my assignment.
When do I?
Yeah. If,
Like,
any-
there's no real. Like, I think everyone's sort of in the.
if
like,
everyone
hair-pulling.
feels that, why can't we do that? We all agree on that.
Well, it's
Well,
not
it's not
like-
his decision.
I know. It's like it's a good idea.
Email.
Too.
Yeah.
I'm sure they'll do it.
Yeah.
They're pretty reasonable.
Yeah.
But it's like, especially if you're the only one here who like, has.
Oh, this
Yeah.
is so helpful. Okay.
Okay, so this is a phylogram, but of something completely different.
Can you send us something like that? Or no?
Okay, basically we looked, that Guggenheim Museum competition with like 1,700. We looked at every single one and like
Matt, it's your Matt.
divided it down into. Every single one got divided down into a certain category. and then that category we just like diagrammatically explained it. This one's not done. It's missing. I don't know where the final one is. But what's it? Sorry. It may not be there. So. So this is like completely different, but like in yours, I would suspect you have like. So let me just take one last look at this project.
So they want us to incorporate our 5 rules into the
Right.
I just feel like I'm making it like a gym.
Yeah. Okay. So it's a family.
That's actually what it is.
Is that actually what it is?
Yeah, kind of.
Yeah, it's just a family. Okay, I'll go over this and try to. I don't know why.
I'm listening.
Well, this is for something completely different.
Showing what a clever girl is.
Where?
Worse than most.
Yeah, there. Laura was just talking about dinosaurs.
Oh, yeah. I was thinking about that. But yeah, same thing.
It's not. I didn't realize like my thing built in 3D geometry.
Oh my
It
God.
took all of it to apply it to. I
Just
think
learned out it's not.
I don't have
80%
Grasshopper.
of the
I think I'm just gonna redo it.
So, do you have time after class to look at this?
Not directly. Well, possibly directly after class.
Okay, yeah, because we have this to do it too. So whenever, before 2,
I don't
That'd be
know
great.
like, what I've been exploring, like to apply that to a nebulous surface doesn't add to my because I've been trying to develop something for studio to solve a studio problem, right? And it builds it builds a thing. It doesn't apply to a thing.
So you think they'll probably just give us an extension?
You think?
I would think so.
I mean, it's not your choice.
Yeah,
obviously.
I can't. I already got my kind of stuff on there.
Well, if it was a class one,
Yeah.
Class
different.
extension would be amazing.
No, I
Even
know.
just like a day.
But I probably should not send the email in general.
Wait, what happened? Oh, right.
I can send it. If you send an email, I can send an email as
If you
well.
send from that preference.
Yeah, I pretty much can't go on with my project until I get some advice.
For this? For drafting?
Yeah.
I think I just need to redo it.
Maybe we can like the whole, well, if you were here on
But the
Monday
thing
to
is,
help
like,
us out, then we
it's
would
like,
have been able to
you
do
know,
this.
I want to actually like explore something that helps me further, not just do another like paneling assignment that we did last semester.
Oh yeah.
Right? Like that doesn't help. That doesn't. You know what I mean? Like I've explored paneling, and I don't want to do another paneling assignment. I want to do something that helps me in studio.
And that's what this is supposed to be.
It's supposed to be about, but my studio. So about the 3D part, like if our script builds 3D geometry, does that count? Because that's the part. Like I've been writing a script, and it doesn't apply to a surface. It
Right.
builds a thing. Is that legit? Because I don't. It says you can just consider using applied definition of 3D proxy geometry, but like what if our definition builds a 3D geometry?
So, like, what does it?
Here,
What does it do?
I'll show you mine for example.
Okay.
Yeah.
Like, I'm trying to simulate cigarette smoke.
Right.
So like coming from a source and like, you know, very swirly, dispersion stuff. So this is basically like a 3D geometry.
Right.
There's no way I could apply that to a surface. Unless I just like made it into a 2D pattern and just blah like all over it. And I think that's just maybe stupid. So that's my new one.
Yeah.
I'm
Let's.
on the same page as him, like I know how to use paneling tools. I really
Yeah.
want to learn that again.
I guess what mine does is it basically it subdivides a greater like a cube into smaller cubes and then basically like warps that to like
Right.
basically like imagining like a dissolve, right? Dissolving from a cube into like an infinitesimal small cube. Right? It builds 3D things. mean, that's what I've been playing with. Like, if I have to do something different, I guess I can change it. But I'm trying to solve a studio problem with it. Like, that was my understanding was we're supposed to use graphics to help us in studio.
Yeah, he gets it. He's just really
Yeah. See, it does
say like it could be a 3D. It says it actually stipulates if you're not doing something in 3D, then you have to make it 3D.
Yeah.
So I took that as like the best answer is to do something in 3D. So, like this is what happens if I make a 2D. Like it can make 2D images.
Right,
I could just plaster that all over something, but it's just going to look terrible.
I would say it makes sense that, and there's, do you have like, can you make 16?
Yeah, easily. Like it's just, yeah, I'll show you what
you have a bunch of different variables.
Like I can keep adding more and more variables to it.
Yeah.
And like it's just field lines and attractors and charges.
And then I guess my other question.
I would say that's okay.
Yeah?
Yeah.
Like I think it's more interesting than putting hexagons on a weird shape.
There. I said it's okay.
What's that?
I said it's okay. Okay. We're good.
If our thing is building like a three-dimensional mass, then that's and I mean the variables will change the way in that three-dimensional mass are built, right? Like, and right now I can plug in curves, I can plug in image files to like as variables and as change.
I'll just really explore it and like make it into things that aren't just curves, like do extrusions and stuff, and like
Okay. I would say that's okay.
Okay, thanks, Matt.
Hey, copying your command boxes with just
like
the drag copy.
I am just copy and pasting.
Oh,
Control C and V.
I thought you were
I know they're used to
drag copying, but I don't think I've tried to control it.
When I first started using Grasshopper, I was positive there was like a drag copy, but it like disappeared at one thing. So I just, what did I just do there? So I just like straight up like Control C and Control V. Okay. But like if you go from file to file, it pastes it in the exact same spot it was. So like if you copied something from way at the bottom and then go to a new one and paste, it won't look like it. Yeah, it's way down there. So.
Hey. You're here. I'm going to ask you a quick question. So, with this script, since you have it in a bunch, like I did the Hallmark house, but it's like in lots of pieces with all these, like from the drawing that we did all those are separate type of elements that you're creating. So in the end, should I just be like, okay, extrude some of these or whatever so that they're three-dimensional, so 2D, and then join them all together in like one V-rep, and then panel that thing? Or
I would. I think you could. I don't think you need to. Well, you could probably do this without having. Like, you wouldn't have to panelize your project. Really. You could find other ways of like varying through like the extrusions and stuff without having to panelize it. I mean, you could like just extrude it up, and then use like that like as a base shape to then panel like surfaces.
okay.
But you might
Like three tiles essentially.
yeah. So you might, but like you might want like if you don't want to do that, there would be you could just use the actual like extruding as like your variable or.
It's 1 of 16.
Yeah. Well, no, I mean, extrusion, you might want more than just extruding. Like maybe you did something else to it, but like extruding it 1 versus like 10, or extruding some of the different amounts. Those could your 16 could come from different variations on that.
So instead of, but don't I still need to apply this to like the surface?
Well, like if you've made. Well, how are you seeing it going to the surface?
I don't. That's why I'm concerned. I was like, okay, maybe if you made a surface that was like 4 panels and then essentially it becomes a tile. And so it would be like 4 tiles on
like if you,
a box. I don't know.
This is just completely flat, right?
Yeah. Oh, yeah. Not made anything vertical, yeah. I just want to see the surfaces to make sure that the boxes were doing what I wanted them to do. Not that the surfaces are precious.
Yeah, I guess, yeah, that would be, like if you extruded, because it's flat, it's relative, like when you extrude it, so if you extrude this piece here, and then explode it, you're going to get a bunch of squares basically, right? The surface, the surface, the surface. You can use, if you use those to put like, something on it, or even you could like extrude them and then like if those are extruded, your variations could come between like boolean parts out of it, like basically whatever. But yeah, maybe start with like, extrude it up and then use those surfaces just to.
I was like, maybe throw tractor points in and then all the squares kind of jumbled to like one section or wherever. Although the tractor point has to collect from 4 different data entries, so it might be confusing. There's like, yeah, I think I have like 4 different data streams going on. Or should I just like delete some of these things and be like, simplify your life?
Well, I mean,
and yeah, I just realized I use panels as like labels rather than actual.
well, that's what I do that sometimes. So like these are all, what are these? I mean, you can start, you might want to start, like, so you have these all, like you have 4 different, or a bunch of different things, right? So each of these is like controlling this or this, right? You could give each one a, like something it can do. So like maybe these like move out, or like these move out, or they move out, whatever. And then use like tractor points, and it will affect kind of all of them. And and they're all varying in degree.
Try.
So sorry, what did you create here? Okay. Well, I mean, like this, like even its own itself, you could create. You could like your variation could come in. Like first, you could extrude it so it looks exactly like this, and then based on other things, you can create completely different like final versions just by either extruding them or maybe extruded like Chris extruded like little points. Like you could get your variants through the actual like creation into a 3D shape instead of like creating it and then kind of inside for right. So
okay, so don't apply it to the surface.
Yeah.
Just try to vary what you already have.
Yes.
Okay, I'm quoting you.
Yeah.
Yes.
All right. Okay. Okay, I'll get started. Just in relation to the assignment, I know it says to ask for a phylogram, and I didn't know what a phylogram was before like the beginning of the semester. So this is for a completely different thing and completely different project, but it is a phylogram. So what we did in this project was go through like these are all the submissions to the Guggenheim Finland or Helsinki competition. So we looked at every single one, all 1,700 of them, and classified them into kind of like a family tree. So starting at kind of the major.
Hard to get past that part.
Yeah.
17.
Yeah. So like they're kind of like main design theme, or so diagrammatic, sculptural, and then contextual. So those are like three major categories, and then from each category from there, you get further down and further down and further down until we had I think it was like 32 final categories, and then each of those, each of the projects, like these, we then diagram. So these were kind of sculptural, representational, inward-facing, lifted, curved, right? So that's all these ones were in that kind of category. And then, in the actual phylogram, you see that family tree of each one. Each one located here is this, 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 and then this, right? So in kind of your example, I would, off the top of my head, think these be like your major variables. You probably won't have this. You won't have this many branches. But these being major variables. So under this one, maybe these two stay similar, but then you change. This one is the one you're changing. So then you get a bunch under here where this one's changed, or something like that, right? So when you see, so if something was under like something here, you know that kind of the variables that were used to create it. That makes some sense.
An example of a variable? Do you mean like a length change?
Well, yeah, you could just say maybe you had like height, like the height of your objects, your thickness and like density, or like whatever you've kind of coded in as kind of your major things. And then you could.
Sorry, it wouldn't be like the curvature or
Well, I mean, you could then in here say, the height is being based off curvature or manual, and then have some here that are then curvature, height, your project, and then some here that are manual. But I mean, you could go.
So this would need to add up to 16.
Yes. Yeah. Or you could have like curvature ones, like manual, image map, and then from here you go changing the height or the width or density, and then you have some here. So just so you know, just so it's easy to see, and then when you render, I think it asks for 5 that have to be kind of presented. Then you have your 5, and then you could just say, this one is, here on the tree, so you can easily see how it was created. So I think it asks for, it asks for the file, so the phylogram has to show 16 paths. They don't, I think it was mentioned, they don't actually have to be shown, the final versions don't have to be shown or rendered on the board. Only 5 do, I believe, right? Right? So in the phylogram, you can just outline all the variables, and then I know, on this one that we did, the final kind of row wasn't pictures of the buildings. There was still 10 or 15 in each little section. It was just a small little diagram kind of highlighting what it was. So that last row can just be either kind of the variables used, or they just have to show show that you had 16 different kind of versions. So it doesn't have to actually represent it. It's just I would say the variables that were used in that thing. So if you use image maps, maybe you might show the image map on that one. Or if you manually did it, maybe just the actual values that you had entered for that one. And then for the 5, you can show on the phylogram where those 5 were, where they came from. And then it's easy for someone looking at it to see what variables were used to create that one.
So, the design would be on your phylogram would be our surface, or would be the thing we required.
Yes. Well, yeah, you might have the first one be the actual parameters, and then maybe the second, or maybe there's only two levels, or there might be 3 levels. The following ones actually just be, so if this was thickness, maybe this was thickness being changed, but the other 2 being at 0. This was thickness being changed, but the other 2 at 50%. And then here you would have the other 2 being at 0, 50%, or sorry, the other 2 being at 0, thickness at this value, thickness at this value, thickness at this value, thickness at this value. And then the ones under this one would be the other 2 variables at 50%, thickness at this, thickness at this, thickness at this. So you have you would have 6 outputs, or however many outputs there. Or this one could be, image map, manual values in. Just however you've even if you're just sliding values around, there's some sort of logic you're using, even if you're just kind of randomly doing it. So just try to document that, if that makes sense. Yeah, if you Google phylogram, it's just butterflies, and I think there's one architecture studio that did it, but you won't ever find what they did. It's hard. Question?
On our assignment sheet, that's for a diagram of the channel. Is that
At one of the first steps was that this right here, produce a diagram of the.
No, down at the deliverables, that's for a diagram.
No. All right, so I think that is referring to. So it's not if you had to make a diagram of your definition, like what it's doing, that would be that. So, yeah.
Isn't it also for screen capture?
No, so not a screen capture of your. It's kind of like this.
I thought that was a diagram outside of.
No, you don't have to make the diagram in Grasshopper. Oh.
But business diagram, you put on like whatever you pick, either press it in or whatever.
Right. Sorry. Yes, that's what it is. So if you had to, yeah. So what you said, if you had to, like, create a diagram of what your thing is doing, or what's like governing the creation of it, that is that. So I think it was like the example Britt did of the coffee. So, you know, if you're looking at the final thing, how could you, like, what are the steps to kind of create that in the, I don't know, so it's like this, yeah. Well, I mean, it's the real world abstract, yeah. But I mean, looking at this is how I would make the Grasshopper definition too, right? Start with a curve, right? So it's kind of the,
So producing that will actually help inform.
yes, that's why it's in step 2. Yeah. So you should have a clear yeah. So this is kind of like even if you're just doing it in your head previously, like you look at the final thing, like how am I going to create that in Grasshopper? This is the diagram that is explaining how it would be made, like kind of in the real world, but it also is how you would make it in Grasshopper, or kind of anything really, right? It's the logical steps of how you get from the nothing to the thing. That would be easy to follow, like those things on the wall. Some of them.
Right now my arm doesn't getting out of control. And I think the more details to add, but I kind of like to stop at one to
Yeah. You don't want to make it too, but I mean, just like any architectural diagram, it kind of simplifies things slightly, right? You know, suddenly like the square turns into like, they've broken it down into easy to understand kind of steps, so that when you look at it, you can see the complex thinking in the easy way. So, I mean, I would try to do that as well. Like, kind of, you know, if things get super complex, then yeah, you can probably kind of combine steps into one, or kind of make it a little more simple. But also, that's going to help. I mean, if it's too complex, you might want to rethink like exactly what you're trying to do. You know, if you can't even explain it in a diagram, it might be kind of hard to Grasshopper. All right. So what I have here is the exact definition that Brett had for his coffee. So if I...
Sorry, we're recording?
Yes. We are. All right, so if I just turn this on... Oh, sorry, if I turn this on... Slow. All right, so there it is as he designed and he left off. So kind of an important thing to look at, if we're going to put this definition on anything else, is like, what is it asking for at the beginning? Like, what are you actually inputting? And basically what it's doing is it's getting a curve, which is the outside, and a surface. So we just know like it needs that no matter what. Even if we're putting in this, we're going to have to get a curve and a surface, right? That's what it's asking for. Just to see, and here we have a square. Obviously it wasn't designed for a square, but let's just give it a shot. This is the exact steps I went over last night to see how this would work. So let it think for a second. There. Alright, so I mean it's not, obviously coffee cups are usually not square, but I mean the actual definition is working, you know, pretty much the exact same depending on the actual shape we gave it. So when a kind of closed, or on a 2D plane, I think it's working pretty well. So now, see this is the same shape I had before. See, whoops, curved. But here, before when we had just the curves to input, here we just have a surface. So I'm going to have to get, to even have it work at all, I'm going to have to get surface and the curves. So that's not that hard. We just go surface. Right, so I'm going to input the surface here. And then to get kind of the edge curves, I'm just going to do the exact same thing I did in that last example, is deconstruct. And then join the curves. And what you have here is the edge curves all as kind of one curve. All right, so I'm going to just copy this. And usually when I'm doing this, like, it's kind of smart sometimes to turn off, you know, you don't want to be testing the whole definition all at once, because sometimes it will crash your computer. So I usually turn off, you know, go step by step through the definition and see what is working and what is not. All right. So let me just turn this off. We have my curves here and my surface. So I'm just going to replace where these are all going to. The curve goes here, and then the surfaces are going here. Actually, the easy way to do this is this. There. That's why it's sometimes a good to start with. Like, use these a lot to replace things instead of replacing all 5 lines. You just plug it into there. All right. So let me turn this on and see what happens. All right, let's go to here. All right, as you see, let's try to stop scrolling so much. It first is taking the surface and it is populating it. Right? So populate geometry works in 2D and 3D. So that part is perfect. Divide, this is the one that was just dividing the kind of outside curve. Again, it's kind of working as it's supposed to. This part here is, if we remember, taking these kind of interior points and moving them towards the edge. So you'll see that for the most part that is working. We're getting kind of points pulled towards the outside, and it's kind of gotten rid of any points in the middle. You'll see though that if I turn on the vectors, this was how to view the vectors, it's not pulling the points along the surface, it's pulling them kind of directly to the edge. So you start to get points that are no longer kind of on the surface. So I mean, that is problem 1. So I mean, off the top of my head, the easiest way to fix that is just use like closest point and pull them back onto the surface. So if we do that, and you'll see, I'll turn the rest of it on. Before, you use those points to then draw spheres. And if I turn these off, you'll see that while some of the spheres are kind of relatively close to the surface, we do have a bunch just kind of floating kind of in space. And then when you use the surface to cut them, so they're only kind of bubbles and not full spheres anymore, a lot of them are just completely off the surface, so that is not happening. And just you'll find that nothing slows down like Grasshopper more than Booleans. So for the most part, I try not to use them at all. But I'm just going to keep this Boolean off for like the whole time, just so when I make changes, it actually responds. So I guess an easy way to do this, again, is just surface closest point. So there I'm going to take my surface, and that goes into the S. The point goes into the P, and now I have those points kind of back in the surface, back on the surface. And I'm just going to use this new point instead of wherever move went. So that goes down here. Again, let me just turn this off so this works. Right. So that works. All those bubbles are now back on the surface. Right. And then if we go down here, so bubbles, sphere to dome, we turn this on. So what this is doing is basically splitting, or just kind of dividing this in half, or cutting the spheres with the surface. And what that does is cuts the wrong side, or no, sorry. It does if I turn this off. It cuts out the wrong side of the thing. So now we have the bubbles on the inside, which you might want. So there's a few ways of doing this, but again, I tend to not use solid difference, and it's really not even the right command to use here because this is just a plane and it's not a solid. So what I would rather use here that's going to work, I think it's going to be quicker and give us the option of what side of the sphere we want is split instead of solid difference. So if I put the sphere into the one and the surface, which is the cutting thing, into the second one, right. So what that gives us is basically a list, or a list of each sphere in its both sides. So it's a list of two, one side, one the other side. And all we'd have to do there is list item. And then we're just going to pick the side of the side we want. So it looks like the first item is the inside one. If we go to the next item in the list, it is the outside. So I mean, with really only one command, surface closest point, and just switching this up, we got it halfway there, and I thought I was on a roll until this command here, which, if we remember up here, is what is creating it's what it's creating all these lines here, which get trimmed down into kind of the swirls in the liquid. So I haven't used this a lot, but unfortunately it says it only creates kind of 2D things. So this command here is not going to work at all in 3D, but there is a way. There always is. And this technique might be what some of you use. So what we're going to do is basically not start this script all over again, but use it to create our kind of final output on a 2D plane. So do all the calculations, create all the lines on 2D, and then like it just magically wraps itself on a 3D shape. Not magically, but all right. So I mean, this is exactly how I went through this when I was looking at this for the first time. You know, I plugged it in, I started going through it. I was starting to fix things so it kind of worked in 3D. There might be some things that don't work exactly the same, but you might even get like more functionality, you know, just from what you kind of experience and what kind of happens when you put it in 3D or onto a curved surface. So, but here, this command unfortunately doesn't work, and I'm sure there's some way that you could get something similar just by fixing this and doing it somehow, but from off the top of my head, the easiest way is to then, instead of doing this and starting in curved, getting it completely worked out on a surface in 2D and then wrapping it around. So to do that though, I mean I could take that original circle and try to wrap it around my new shape, but because they're not similar like dimensions and similar, they're not the same typology or anything like that, you'll get stretching and it won't work right. So what we have to do is get our surface, approximate a flat plane that is the same size, create our script and do all our stuff on that, and then transport that information onto the curved surface. So let me turn these off. All right. So to create a kind of flat plane that is the same size as this, all we're going to do is use the dimension command. So it's going to give us kind of the U and V dimension, so the dimension along this here and the dimension here. And that we're going to use to just make a rectangle on the ground. So if you flattened this out, it would be approximately looking like this. And this is what we're going to use for kind of all our inputs at the start. Right. Again, it's asking for a surface and a curve. So here we have, I believe this is a curve, right? And what this was doing in the original one was making that curve into a surface. So we're just going to do that again. Except I did that somewhere. And this one there. Right. Right, so using the command I did last time, actually got to change this back to there. All right. So I have this working basically on the flat plane, and if I turn this part back on, what we're getting here is the exact same thing as we got up on the circle and the square up here. The only difference is that it's a lot bigger, so you're not seeing all those ripples combining. But if we cranked up this population here, now going to take forever, but. How was everyone's block week? Alright, I shouldn't have done that. But I'll turn it back after. You should be. The last yeah. If they're... They said they were going to be before this one, right? They should be. I'm pretty sure. I'll have to check, but I don't see why they should be marked already. So I don't see why they shouldn't be available to you yet. Yeah. Yes. The thing you can tell how it's working still is in here. So it says it's not responding, and that's why it looks like it's crashing. But if it's still working here, it's still working. Yeah, I don't know why. Hopefully in Grasshopper 2, which is in development, it should tell you, or at least be able to cancel something before it takes like hours, potentially. This won't take hours. It shouldn't take hours because I only increased the number. But yeah, the only way to get out of this would be to like try to escape, and then it will crash Grasshopper. But it is, you can tell if it's still, if this was at 0, then it'd probably be crashed. But it's still working. So, but yeah, that's why you can always, it's like right when you let go of the thing, you know that it's going to take like, you're just like, ugh. And you haven't saved, and you know it's just going to take like hours, so you just cancel and come on. Sure. But that's not it. So oops. Right. So it's, yeah. Yeah, I believe it says, yeah, so a minimum of 5. Yeah. So the way I'd probably, well, I would probably lay it out is, yeah, you have your diagram explaining your system. So that's this one. You like identify, so that's this. You identify like what variables you're going to start changing. That kind of leads into your phylogram, and then at the end of the phylogram, you'd have kind of 16, iterations, and then, reference those 5 like from there. So to make it clear, like what one each one's from. Yeah. So. Yes. The phylogram might like extend. It could extend like between your two boards. I mean, don't put information like about to get cut off, but you could. I mean, there's the lines and stuff would most likely be able to. All right. Yeah. So as you can see, it is doing kind of something similar. It's just due to the scale. I guess let me change this to 20. Right. So yeah, it doesn't look good, but we know it's working. All right. Okay. So we have this basically good to go. So we want to get this onto this. And I'm going to do that kind of separately. There is the one command is map to surface, and that's going to map curves from kind of one plane onto a surface. So that's step one. That will get the curves. And then I'm going to do something different to get the actual points. And then the points will just create the spheres, similar to how that last example was. So this right here is our curves, and the way it was done is it's only giving us the curves that are kind of around the balls and not in the center, and it's culling that. So we could continue to use this, but if you look at this thing, we have curve, a bunch of ones that were gotten rid of. There's another one, so it's full of things we don't really need. If you go clean tree, it's just going to remove all null and invalid items from your data tree. So if I put that in here, remove null items from the tree is true. So if we look at it now, it's only the curves we want. And then we're going to use map to surface. So this maps a curve onto a surface via control points. And I'm pretty sure that's what I used. Right. So it's just going to ask again for curve, base surface, and target surface. So our base surface is kind of the one we used to create this. So if we go back here, that would be this, right? Here. This is our curves, and then our target surface is this one. So that is actually, we don't have that one in there yet. So that is our target surface. And just like that, you'll see that these have been put, there's not very many at the moment, but they are all been placed, or most of them. Where'd the other ones go? Here, let me just hide this. Okay, I guess I only have 3. I can turn that up a bit in a second. 20 was too low. There. So you can see we have a bunch of the curves now placed on the surface. And I believe they are directly, they're directly on the surface. So they're they don't actually leave the surface at all between their control points. Like those are mapped to the surface, kind of point by inch by inch. All right, so there we have the curves, and that's an easy way to, I mean, it is true that especially with curves, it's a lot easier to do it on a flat plane, just because, especially if you're trying to put it on a curved surface, there's no real way to draw and follow the surface like in Grasshopper. So usually I would use those kind of steps, approximate the surface that you want it on, make it flat, do kind of what you want to do, and then map those curves. And you could also actually create, like you could create a grid this way, or like a much different paneling kind of system. Kind of like a weave or anything in this, and then map it onto a more curved surface. Now for the points, how we're going to do that is we're going to take, so I know Matt and Joni went over like U and V coordinates, but just to kind of reiterate, the U and V coordinates is basically the coordinates of a surface or a geometry. So this has coordinates 0, 0 at one of these corners, and then depending on its size, it has like another 2 coordinates at this corner, so like 500, 500 if this was a square. And all these points have a coordinate not only in the whole world, so this might be based off 0, a certain one, but it also has coordinates specifically for this. And this one as well has similar coordinates. So if this one here is like 20, 10, we can then map this to this surface at its 20, 10, which is basically in the exact same spot, but on this surface. So that's what we're going to do. We're going to find the UV coordinates of all these points that are making the spheres, and then translate those points onto the surface, and then just make the spheres again. So we're not actually, you could try to move these or map them, but the easiest way and the most accurate way is just to use the UV coordinates. So step 1, what is kind of a good thing to do most of the time is, so while we did use this dimensions to create these, odds are they're not exactly the same dimension, because this actually might get skinnier between the two sides. The two sides. So this square is not like an exact replication of this. So this might go from 0 to 600, or it actually goes to 0 to 246 and 0 to 226. So if we were to use those numbers to values to this, they might be slightly different spots. So what you can do is, if you take kind of your surface, so this is our surface here, and reparameterize it. And basically what that does is, instead of going from 1 to whatever dimension it is, like 260, it now goes from 0 to 1. And this one as well goes from 0 to 1. Right? So 1, 1 will always be this like exact tip, and it's just a lot easier to relate two items together when you have them reparameterized to both 0 to 1. So then, halfway through this corner will be exactly halfway at 0.5, will be exactly 0.5 on this other shape as well, instead of trying to deal with dimensions and coordinates that might not be exactly the same. So all that I did there was right, and you'll see that things that can be reparameterized, the reparameterize option is there. If you just try to do something, well, that one you can. Things that can't be, that option isn't there. And you'll see now that if I use this, if I find the UW or the UV coordinates of something on this, they'll all be between 0 and 1 and not kind of 0 and 200. All right, so I'm going to do that to this other shape as well. So that we have here, right? So both surfaces have been reparameterized. All right. So I still had this surface closest point in here, which I didn't actually need because it was flat. But at this point, you'll see that all the points that are making these spheres also have their UV coordinates here. So to translate those, I'm just going to go evaluate surface, and then I'm going to put the curved surface into the top, here. And then these UV points into here. And now these points that make up these spheres have been translated pretty much exactly to this other curved surface. Now if I just use these points here to make the bubbles, and then instead of using this surface to cut, use that curved surface to cut. And then, oops. There. Now if I turn that all on, and now I'll turn this up back to something that makes some sort of sense. Yes. Almost every Rhino one has some sort of... Actually, I looked for flow before. Flow might... Not all of them, but a lot do. Flow along. All the, like, sweeps and, like, all those... Most do. And most have... Like, if you Googled flow along surface Grasshopper, there is a way to do, like, copy that exact command. But see, there we have basically the exact definition again, going into kind of a 3D surface. And if I turn this on, we now have our coffee film in 3D. And then, you know, this could be, now that it's set up for like any curved surface, I could replace that with almost anything and it should work the same. If I put something like a sphere or something completely closed, well, a sphere doesn't have edges to pull to, but if I put a cube in here, you might have to make some other changes. Really, the only change would be you would take a cube and then explode it into its sides, and then you basically have like six flat planes that the definition can go on, and then that's basically even easier than this curved surface. But
the whole idea with this is that the surface that we're taking our geometry and applying, we're really just applying patterns. Like we're not really changing, you know what I mean? Like that shape, that form.
yeah, I wouldn't.
There really is just getting a pattern. Like,
Right. So I guess there's two ways. I mean, you could do it a couple ways. You could have a like set surface. So this is what like I guess the assignment describes really. It's you have your kind of material system, which is your definition, and then you have a 3D shape, right? And then you're combining those two. And then it's not the shape that's changing, it's the variables of like your material. So in this example, I could change, I mean, I don't know if it's set up for the best way to do it, but it would be the definition that changed, not the actual surface. So it'd be like the amount of bubbles, the bubble size, the amount of the curves left, stuff like that. Yeah.
It was confusing to me because I was thinking that we were building this
Right.
thing in order to change the shape, but we're not. We're just
No.
allowing the shape
But-
to inform.
Right, but you could, like if you had a shape that created more of its form, like it might start off a flat surface or like a single point and create its shape through its variables, then in that case, I mean the variables would kind of change the shape itself. But I mean I think both would be acceptable. So, I mean, yeah. I would say both would be acceptable. So yeah, I mean, keep your shape the same and then change what's being applied to it is kind of the main way to do it.
Are you going to show how to apply it?
I can, yes, sure. Let's, can I do it in here? Let's see, the other one might be better to use. Jeez. Okay. So we had curvature controlling the opening, but let's okay, let's delete that. Okay, so for image maps, the first thing you want to put down is the image sampler. So that's just where you'll put the actual image. And I have a bunch in here. Alright, so on this screen here I've loaded the image I want, and I believe it's just a JPEG, so it can kind of be anything. So it shows the image kind of in a 0 to 1, and if it looks kind of squished or it's not like the exact aspect ratio, that's okay. But on these ones, this is basically what it's kind of reading the image for. So almost all the time I've used color brightness, which is this last one. But what it's going to do is basically look at, in this example, the brightness of the image from black to white at each kind of, each coordinate that you give it. So ignore the grid. The grid just kind of shows it's relative to 0 to 1. But at each point you kind of put into this, it's going to test what color it is, 0 to 1, white to black, and just kind of output that. So you could use, I think there's other ones in here like the saturation and all these other ones, but I've always just used white to black because it's kind of the easiest to control. And it's going to output something 0 to 1. And there are a couple ways to do this, though I found this way to be the best, is to keep, again, to make something reactive to what you put into it. You could change this domain to the size of your surface, which makes it easier. Well, it doesn't make it easier, but that's kind of like the first thing you would think of. But if you've reparameterized your surface, it is now between 0 and 1, and your image here by default is 0 to 1. So like the top corner of your image surface will be the top corner of the image, and that makes it way easier. And it will always make your surface an image like 1 to 1. So one image goes over the whole surface. If you have your surface not reparameterized, and it's like 100 to 200, or sorry, 0 to 200, and this stays at 0 to 1, you're going to get your image tiled along it like 200 times. So reparameterize your image and keep this 0 to 1. So let's just press OK, and it shows you the image. So what you're going to want to put in here is basically points between 0 and 1. So 0 and 0 would be the top left corner, I believe, or it might even be the bottom left corner, and then 1, 1 be the top right corner. And we were getting those points basically through the same way I did to move the points from the one surface to the other, is just to evaluate this, or get the UVW coordinates of those points, which I believe we found somewhere in here, or maybe not. Yeah, right here. We've already found our surface closest points. As you see, we never, did we? No. I had never reparameterized it, so now all these points are not between 0 and 1, but if I go back here, reparameterize, sorry, you'll see that all those points are now between 0 and 1, so they line up with kind of the coordinates of our image. So if we put those points in here, we're now going to get 275 basically values back between 0 and 1, which is the amount of whiteness in the image. And again, similar to calculating the curvature, we most likely want values not 0 to 1. So in the same way, we're going to use remap, except it's a little easier this time because the source domain is 0 to 1. That's just by default. The values to remap right, so now we have this image here directing both the height and the aperture of this here. So you can see, I believe it's doing it, so it's kind of lining up like that. So that black spot is here, or no, sorry, it's actually like this. The white values are higher, or sorry, the black values are higher. No, wait. Sorry. Yeah. I just had it going backwards in here, but. So you see that the black spot in the image is making this dense part here, and then as it gets to white, you can see that change like that. And I use this a lot, even in probably almost every definition I have, because you can easily change the design of this with, here's the things I was talking about last time, where obviously they're not really scaled to this, but and then quickly get this one even says something, though I doubt that will show up on this, but no. And again, that was just getting the UV points, passing it through the image sampler, and then remapping them to values that were actually usable in my definition.
So in the assignment, it asks for a minimum of 2 of the iterations to be informed by external drivers. So that would be 1 being like an image map, and then the first one would have been a curve.
Right.
So do you then write the definition for both and then plug them? Or could it be 2 variations of image map?
Well, you could have it, the image map doing controlling one variable, and then the curvature controlling a different one. So they could be being used at the same time. Or, put multiple, image maps. Like here I've got the same image map doing both things. But it's easy enough to have separate ones throughout your script, changing different things. So I would try to put as many, well, not as many, but a couple, like have them be doing different things, and then you can change how the curvature is affecting one thing, and then you can change how image maps controlling another one, and that gives you like a lot of control over almost a bunch of variables. And I don't know if I have, there's like plugins are the greatest. So like this one here takes a Wii controller. There's a lot that deal with sun and like climate data, so it's real easy just to, you can download like the data of a spot and then use like the hours of sunlight for something. Again, some taking like spreadsheet data. So I know this is not this project, but in the past I have a diagram generator. So I just put in like my in an Excel file, just put in like the program, so like the areas, the name, and their adjacencies, just in a script, and then it makes like 10 different diagrams relating all those things. And I mean, it's easy because I mean they all look similar. Well, from project to project they look similar, but it's like a real easy way just to like visualize you know, areas of spaces compared to each other. So I mean, it's these external drivers are, I mean, there's a plugin for almost anything. So you might want to just explore and find one that's kind of different than just an image map and curvature, but certainly those are ones that I use a lot. So I don't know what these are. So were there any questions about either the image one or kind of how I went through the coffee example? No? Any more general directions? I mean, general questions about your assignment or a problem that you've run into? A bunch?
Will you have this uploaded relatively?
Yeah, I can do that like right now. So I'll try to drop by the studio. It's at some point today. You know, you have studio today, right?